Welcome back. In this video, we're going to use linear programming to solve an optimization problem. The one that we've chosen, it comes from the Jaggia et al. Business Analytics textbook, example 17.2. And the file that you need for this is parkas.xls. That is in the both as a download from the textbook and also in the course itself. Whenever you downloaded the Excel spreadsheet, it should come in and it will be blank. Now I've already filled some stuff in here, but yours should be blank. One thing you need to check is that on the constraints, that it's possible that your fabric and machine time have been switched. So make sure that you have corrected this back, move one of these down and back up again so that they match up in line with what the parameters are. All right, next thing that I want to make sure you do after you get that correct is to make sure that you can get Solver in your Excel spreadsheet. If you go to File, down here to Options, inside of Options you should see Add-ins and Manage Excel Add-ins. Make sure Solver Add-in is selected and click OK. You'll know that it's there now whenever you go over to your Data tab, and you should see Solver as an option. Second thing we're going to do, step B of example 17.2, is to add the parameters. All right, now parameters, again, this is an optimization for the Fashion Tech company. Fashion Tech says that they have two products. They make jackets and parkas. They want to know how many jackets they should make and how many parkas they need to make. There are parameters for each one of the items that they have. Fabric is 8.5 feet. You get the rest of it. Parkers or fabric is 12.5 feet. This data comes from the example, but also comes from, again, example 17.2. So to finish step B, you should be able to finish filling in this information here. Next, we need to be able to put in the constraints. The constraints are in step C, 4,000 feet of fabric, 650 hours of labor, and you see the rest of it. Whenever you finish everything in step C, what you should have is this information filled in and this information filled in. All right, that takes us over to step D. Step D is telling us it's time for us to set our objective function. This is the objective function that we're looking at, and what we're doing in the objective function is we're trying to maximize the amount of profit. Profit comes from the number of jackets times the profit per jacket, the number of parkas times the profit for parkas, and to get that you are going to need to enter the formula equals sum product B8 through C8 times B11 through C11. All right. How many of these times the profit? How many of these times the profit? That takes care of the objective function. Next, in this, we want to make sure that our value comes out correct. So if you type in 1 for jacket and 1 for parka, again, just put in a 1, put in a 1. What ends up happening is the objective function now takes 1 jacket times $9 plus 1 parka times $12.50 to come up with $21.50. So that is just verifying that in step D that we have done the correct formula there. Next thing we're going to do, we're going to move on to step E. And in step E, now we're beginning to look at the constraints. Because every time I make a jacket or I make a parka, I end up using some of my material or my machine time or my labor, which means that down here in this section, every time I make a jacket, I need to multiply that times the fabric of the number of jackets plus the parkas. All right, so again, this is a sum product, B5, C5 times the number of jackets. You're going to do the same thing for your labor, machine time, and whenever you finish that up, you should have all of your constraints put in to where these things should now, if you have 1 jacket and 1 parka, you should be using 21 feet of fabric. You get the point. Next, step F says, all right, now let's look at the units produced to make sure that it's less than the demand. So, number of jackets being made is going to be done here in your decision variable, equals B11. Same thing for parkas being made, equals C11. All right, at this point, you should have everything looking like figure 17.4. You should have all of the data here. Constraints are all listed in here. All of the amount of data that you've done. So at this point, you're ready to launch Solver. Everything is set up for you. So what we're going to do is we're going to go to the Data tab, and in the Data tab, click on Solver. In Solver, step H, we need to make sure that the objective function equals the objective function here. So if you click on Set Objective and click on E4, it should add it to your set objective. Make sure it knows that we're looking for a maximum. All right. Next thing that we want to do, we're going to, by changing variable cell, what we want it to change is, again, if you click here and left click and drag jackets and parkas, we're going to allow Excel to change these two figures. All right. With this objective, we want to get a maximum, which means now that the next step for us is to add constraints. So in the Add Constraints section, what we're going to do in adding constraints, again, I'm at step J in example 17.2. In the Change Constraints, I have constraints listed in B14 through B16. I left-clicked and dragged, all right? Make sure that it's less than or equal. The constraint that I have are left-click, drag, 14 through 16. Okay, so now that should be everything that you need. Click OK. We need to add once again. We're going to add, I'm on step K, number of jackets produced less than or equal to the demand. Click OK. All right, at this point, you should look at figure 17.6 because here's our objective function. We want it to be a max. We want to change cells B11 and C11. We have the following constraints. We want this to make an unconstrained variable, make sure that it's non-negative, because it is possible whenever it's solving this that it would come up with a negative answer. We want non-negative answers. We also want to make sure that this is a SimplexLP, all right? And then once you have done that, if you click on Solve, we want to keep the solver solution, click OK. You should find at this point that you now have the maximum of $3,950 as your profit. And the way you get there, or the way that Excel got there, was it said we need to make 300 jackets and 100 parkas. Okay, so that will get you everything that you need to solving this. Hopefully this makes sense. Good luck.